two numbers, two very big promises. Before anyone can judge either one, there is a simpler question almost nobody stops to ask. What is a hertz, actually? By the end of this file, you will have built one in 3 lines of Python, counted it with your own eyes, and measured it 2 independent ways. After that, no one can sell you a number you cannot check. So, is 528 a special number or just a number? Hold that question. To answer it, we first have to know what the number is counting. This is Foundations, File 1 of the lab notebook, where we build the sound in Python and then measure whether the label is true. Subscribe if you want the rest of the season. Here is a wave slowed right down. Watch one cycle. It rises, it falls, and it returns to where it started. That is one complete round trip. Now, count how many round trips finish inside 1 second. 5. That count is the whole idea. 5 cycles per second is 5 hertz. 200 cycles per second is 200 hertz. There is nothing else hiding in the definition. Which means frequency and time are the same fact seen from 2 sides. If a tone finishes 528 cycles every second, then one cycle takes 1 over 528 of a second, 1.894 milliseconds. Period equals 1 over frequency. Higher frequency, shorter cycle. That is the only equation you have to trust in this episode, and you can check it against any tone you will ever meet. So here is exactly how I build a tone, and it really is 3 steps: a timeline, a sign writing around it, a file on disk. Let us write them. Step 1 is the timeline. Linspace hands us evenly spaced moments, 44,100 of them for every second, because that is the sample rate we will write to the file. Nothing musical has happened yet. This is a ruler made of time. Step 2 is the tone itself, and it is 1 line, a sine of 2 pi times the frequency times the timeline. The 2 pi is 1 full trip around the circle. Multiplying by the frequency says, go around that many times every second. Change that one number, and you have changed the frequency and nothing else. Every pure tone that exists is this line with a different value in it. Step 3 writes it to disk. Scale it down so it can never clip. Hand it the same sample rate we built it with, and there is a WAV file. No instrument, no recording, no sample pack. Now watch what that one number controls and start absurdly low. 1 hertz. 1 cycle takes a whole second. You can see it crawl across the screen. Here it is, playing at full level. That is not a broken speaker. 1 hertz is a real frequency. It is simply far below the range your ears respond to. So the first thing a hertz is not is a sound. It is a rate. Some rates you can hear. Climb the ladder and the same line of code wakes up. 5 hertz is still a flutter you feel more than hear. At 440, the cycles have collapsed to 2.27 milliseconds apart, and that is the A an orchestra tunes to. At 528, they sit 1.894 milliseconds apart. Same code, same line, one number changed. If watching a number turn into a sound is your kind of thing, a like genuinely helps this reach the next curious person. Now we check what we actually made, And we check it twice, because one measurement is only an opinion. Method 1 needs no FFT at all. Count every time the wave crosses 0, then divide by 2, because a full cycle crosses 0 twice, once going up, once coming back down. Over 4 seconds, that gives 527.88 cycles per second. Method 2 is the FFT, which sorts the sound into a bank of frequency bins and tells us which bin holds the energy. It puts the peak at 528.00 hertz. There is the receipt. We asked for 528. The FFT peak lands on 528.00, and the independent count gives 527.88. That gap is 1/8 of a cycle per second, and it is not the tone. A 4-second window ends half a cycle short of a whole number, so the count comes up the same fraction short at every frequency. 2 methods, 1 answer, and the small difference explained rather than hidden. Subscribe. Every file on this channel gets exactly this treatment before any claim is made. So what is a hertz knot? First, it is not a pitch. Frequency is physical. An instrument measures it, and it does not care whether anyone is listening. Pitch is what a brain builds out of it, and brains are not linear. Listen, 220, then 440, then 880. Each step doubles the number, and each step sounds like the same size of jump, 1 octave. Equal musical steps are multiplications in hertz, not additions. Second, it is not loudness. Frequency and amplitude are separate properties of the same wave. Here is 528 Hz quiet, and here is the same 528 Hz louder. The FFT puts both peaks at 528.00. Only the height of the wave changed. Turn a tone up as far as you like, and you will not have moved its frequency by a single hertz. Third, and this is the one the internet gets wrong, a hertz is not a dose. No reliable evidence shows that 528 hertz repairs anything in the body. The studies people cite are tiny, unreplicated, and measure stress markers or cells in a dish, not tissue repair in a person. The naming is worth knowing, too. The solfege syllables really are medieval, from Guido of Arezzo. The set of frequencies is not. Those numbers were derived in the 1990s by Joseph Puleo and Leonard Horowitz using digit reduction numerology on verses from the Book of Numbers. Sustained, gentle sound does help many people settle. That effect is real, and it belongs to the sound, not to the number. And if you want the cleanest evidence that no single number is sacred, look at the most standard number in music. The A above middle C is 440 Hz, but only since an international conference in London in 1939, later adopted as a written standard. Before that, tuning varied widely from place to place. Today, the Berlin and Vienna orchestras play at 443 and New York at 442 because they prefer the brightness. The same note has carried many different numbers. A committee picked one. That does not tell you whether any tone heals anything, but it does dismantle the other half of the story, the idea that some particular tuning is nature's own. One last thing before you go and build your own. A pure tone is one number. Music is never one number. Here is a tone stack built around 528, a fundamental, 5 harmonics above it, and a touch of detuning so it breathes. Listen to it, then measure it. 528 is still exactly where we put it, but it is now one line in a crowd of 18. That is what a piece of music built around a frequency actually is. The number is the anchor, not the whole sound. Build the timeline, build the tone. Count the crossings, then let the FFT confirm the peak. Try 40, try 174, try 963. The peak lands where you put it, to the resolution of the window you analyze. Take 2 seconds and the bins sit half a hertz apart. So ask for something between the bins and the answer snaps to the nearest one. That is the instrument's grain, not the tones. Run it on a number someone has sold you and put the peak you measured in the comments so the next person can compare. So here is the standard. Every signal on this channel is synthesized and measured before anything is claimed about it, and the recipe and the verification are both shown, so nobody has to take my word for it. If that is worth something to you, 3 small things genuinely help. A like, so this reaches the next person trying to check a number. A subscribe, because every file gets this same treatment before any claim is made. And a comment with the peak you measured, so the next person has something to compare against. Next file, the same note, 2 completely different sounds, and what a waveform really is. Sound measured.